Alrighty, everybody, welcome back. AP Environmental Science. This is going to be the final section, possibly the final video for AP Environmental Science. 9.10, we're looking at human impacts on biodiversity. So, seen the Biodiversity Conference report declaring us nearly extinct? Huh? Pickup lines? Get it? It's funny. I think it's funny. Anyways, so how much influence are humans actually having on the endangerment and extinction of species? Well, we know that there have been, according to our research and looking past the history and looking at paleontology and all that fun stuff, that there have been 5 mass extinctions. 5 mass extinctions that caused a huge number of species to go extinct during a short period of time. And then there's background extinction, which is just extinction on a normal basis. So, how much influence are humans having? All right, let's talk about it. The background extinction rate normally is 0.0001%, which means that one species out of every million species on Earth goes extinct on average per year normally. That's okay. Here's the problem. That's the background extinction rate. That's the current extinction rate. The current extinction rate is anywhere from 0.01 to 0.1%, which is up to 1 species per 1,000 every year. Roughly 100 to 1,000 times greater than the background extinction. Many more species are going extinct compared to what we would consider normal or natural. Now, our current extinction event rivals the end Cretaceous, which is when the dinosaurs went extinct. So here's some information on the 5 previous mass extinctions. The first extinction, you can see that we had the Ordovician extinction. Probable cause was an intense ice age, which wiped out 60 to 70% of all of the species on Earth. That was 445 million years ago. 375 to 360 million years ago, we had the Devonian mass extinction, which was probably due to a drastic drop in oxygen levels. 75% of the world's populations were wiped out. 252 million years ago, we had the Permian mass extinction, believed to have been caused by asteroid impacts and intense volcanic activity, wiping out 95% of the population at the time. 200 million years ago, we had the Triassic mass extinction. It's still in debate, but the common theory is that there were massive volcanic eruptions or asteroids. Those are the theories that are floating around. But between 70 and 80% of all the species on Earth at the time went extinct in that event. 66 million years ago, the Cretaceous mass extinction. This is the one that got rid of all the dinosaurs. And it is pretty widely understood that it was an asteroid impact, and it wiped out 75% of the species on Earth. And then we have the anthropogenic mass extinction. It is probable that we are entering a 6th mass extinction, and the cause is Homo sapiens, and it is currently happening. So if we look at species extinction and human population, we can actually see that the extinction rate is directly increasing as human population increases. We can look at some species versus all species. So all species here, this is their extinction rates, the number of valid species. Birds, Coleoptera and Cari. Just to show you some of the data there. Now, why is our current estimate probably too low? Well, population growth and resource consumption, climate change are all continuing to increase. These things are not decreasing. Therefore, the things will keep getting worse. The actual number of species on Earth is actually unknown. We don't actually know. It'd be really expensive and difficult to accurately categorize every single species. And we do discover new species all the time. You can find new species being discovered almost yearly. It happens all the time. It's not new. So this shows you reforming corals, birds, mammals, and amphibians. Coral species are moving towards increased extinction risk the most rapidly. while amphibians are on average the most threatened group. So you can see because they are already likely, this is the red list index of species survival. They're already pretty low, right? Mammals are not decreasing too much, but they are decreasing, birds decreasing. So this shows you risk of extinction. Corals are becoming the higher, faster risked, right? So an RLI value of 1 equates to all the species qualifying as least concern. We don't expect them to become extinct in the near future. 0 means that they have already gone extinct. A constant RLI value over time indicates that the overall extinction risk for the group is constant. So flat line means that we have a constant risk. This means the risk is increasing. Rates are even higher in the centers of the highest biodiversity, or the hotspots, right? Places where there's more biodiversity, that's not good. Potential habitats for new species are increasingly degraded and fragmented, which is causing a speciation crisis because they're unable to create more species with genetic diversity. So remember HIPCO? If you remember it, write it down. I bet you don't remember it. No, I bet you do. Hopefully you do remember habitat loss. What's I? Invasive species, pollution, population, climate change, and overexploitation. I won't make you go through that for too long. That's just, we don't want. I want to make this video less than 10 minutes, and I'm darn sure I'm not going to get there. All right. So this is the number of species that are non-threatened versus threatened based on all habitat loss, invasive species, utilization, accidental mortality, persecution, pollution, natural disasters, diseases, human disturbances, changes in native species dynamics, fires, unknown, and none. So cause versus being threatened and non-threatened. Here's an interesting, fun little quote for you from the National Academy of Sciences. I'll read it to you. The current massive degradation of habitat and extinction of species is taking place on a catastrophically short timescale, and their effects will fundamentally reset the future evolution of the planet's biota. The fossil record suggests that recovery of global ecosystems has required millions or even tens of millions of years. Thus, intervention by humans, the very agents of the current environmental crisis, is required for any possibility of short-term recovery or maintenance of the biota. We caused the problem. We got to solve the problem. So the Great Barrier Reef is pretty much gone. It was healthy in December 2014. It was dying in February of 2015. It was dead in August of 2015. Climate change and ocean acidification has killed off one of the most spectacular features in the planet. The biggest threat to biodiversity is habitat loss. We've talked a lot about habitat loss being a problem, obviously. These are all of the things that are causing those populations to become endangered or extinct. Habitat loss being the greatest impact. Here's an example of wetland loss in Indiana, historic versus 1986. Wetland loss, one dot is 1,000 wetland acres, and then all the counties are there. 3.5% of the surface area was wetlands here in 86 versus 24.1% historically. So wetlands are being degraded. You can see direct lines of where we are doing things and where nature is okay. Habitat fragmentation is a problem because large natural habitats are being broken into smaller, more isolated areas with little or no connectivity. Some of the causes of fragmentation are road and pipeline construction, the clearing for agriculture and housing development, and just general logging, deforestation. How does climate change also impact habitat loss? Well, changes in temperature and precipitation outside of the species' range of tolerance is going to affect them. We also have sea level rises, which is going to lose polar habitat, coastal habitat, and it might generate a new shallow ocean habitat. So there could be a new habitat created from this, but it's unknown completely the extent of that. We also have a decline in genetic diversity. I think I'm going to end the video there, and we'll jump to the last video after this.